Bit manipulation is the act of algorithmically manipulating bits or other pieces of data shorter than a word. Computer programming tasks that require bit manipulation include low-level device control, error detection and correction algorithms, data compression, encryption algorithms, and optimization. For most other tasks, modern programming languages allow the programmer to work directly with abstractions instead of bits that represent those abstractions. Source code that does bit manipulation makes use of the bitwise operations, and, or, XOR, not, and bit shifts. Bit manipulation, in some cases, can obviate or reduce the need to loop over a data structure and can give many-fold speed-ups, as bit manipulations are processed in parallel, but the code can become more difficult to write and maintain. Terminology, bit twiddling and bit bashing are often used interchangeably with bit manipulation, but sometimes exclusively refer to clever or non-obvious ways or uses of bit manipulation, or tedious or challenging low-level device control data manipulation tasks. The term bit twiddling dates from early computing hardware, where computer operators would make adjustments by tweaking or twiddling computer controls. As computer programming languages evolved, programmers adopted the term to mean any handling of data that involved bit-level computation. Bitwise operation. A bitwise operation operates on one or more bit patterns or binary numerals at the level of their individual bits. It is a fast, primitive action directly supported by the central processing unit, and is used to manipulate values for comparisons and calculations. On simple low-cost processors, typically, bitwise operations are substantially faster than division, several times faster than multiplication, and sometimes significantly faster than addition. While modern processors usually perform addition and multiplication just as fast as bitwise operations due to their longer instruction pipelines and other architectural design choices, bitwise operations do commonly use less power because of the reduced use of resources. Masks. A mask is data that is used for bitwise operations, particularly in a bit field. Using a mask, multiple bits in a byte, nibble, word can be set either on, off or inverted from on to off in a single bitewise operation. Example of bit manipulation: the following two code samples, written in the programming language C++, both determine if the given unsigned integer x is a power of 2. The second method uses the fact that powers of 2 have one and only one bit set in their binary representation. x0, 010, 0, x10, 001. 1, x and 0. 000. 0. If the number is neither 0 nor a power of 2, it will have 1 in more than one place. x0. 1. 010. 0, x10. 1. 001. 1, x and 0. 1. 000. 0. If inline assembly language code is used, then an instruction that counts the number of ones or zeros might be available. For example, the POPCNT instruction from the x86 instruction set. Such instructions may have greater latency, however, than the bit twiddling solution. Bit manipulation in the C programming language. The programming language C has direct support for bitwise operations that can be used for bit manipulation. In the following examples, n is the index of the bit to be manipulated within the variable bit FLD, which is an unsigned char being used as a bit field. Bit indexing begins at 0, not 1. Bit 0 is the least significant bit. Set a bit. Clear a bit. Toggle a bit. Test a bit. When using an array of bytes to represent a set of bits, that is, a bit array or bit set, the index of the byte in the array associated with a bit n can be calculated using division. Where n is the index of the given bit and char bit gives the number of bits in a C char. The index of the bit within the byte indexed by the above can be calculated via a modulo operation. Note: unsigned char is typically used in C to represent a byte and char bit is most often 8 on modern processors. % is the C modulo operator. See also, bit twiddler, bit specification, find first set, flag a bit representing a Boolean value, nibble a unit of data consisting of 4 bits, or half a byte, mask, bit banging, bit array, bit predicate, bit manipulation instruction sets, bit manipulation extensions for the x86 instruction set. References: Henry S. Warren, Jr. Hacker's Delight. Addison Wesley. ISBN 0-201-91465-4. Sean Aaron Anderson. Bit Twiddling Hacks. Further reading, D. E. Muth. The Art of Computer Programming Volume 4, Fascicle 1, Bitewise Tricks and Techniques. Binary Decision Diagrams. Edison Wesley Professional. ISBN 0-321-58050-8. Draft of Fascicle 1 available for download. External links: Bit Twiddling Hacks, the gold standard for bit hacks, bit manipulation tricks with full explanations in source code, Intel Intrinsics Guide, XCHG Racks, x86-64 Riddles and Hacks.